Hello, this is Dr. Ogilvy, and I'm going to go through the midterm exam part B questions and look at the images and give you some assessment of each of the questions in case this will be helpful to you as you relearn what you maybe not have learned and prepare for the final exam. So the first question, and it may have not been the first one in yours because we randomized these questions, was name the type of cell circled in the web-like specimen. Now, you must remember, some of you forget that when we ask a cell type, we want a cell type. Now, it's not as important here where you have only cell type choices, but if you have a type in the answer, don't type in a tissue when we ask for a cell type. But in this case, if we look at the image, it asks for this cell type. Well, that's a neutrophil. Just a couple of things. Notice the platelets here. There's a clump of platelets. They're individual platelets, and of course, erythrocytes. There's one that's slightly misshapen, but most of them look normal. And the neutrophil has a bar body, which indicates this was a female specimen, most likely, because of the 2X chromosomes. That's the extra X chromosome showing up there in the neutrophil. So back to the question, you should have chosen neutrophil. So now you need to think about, if you chose a different answer, what that might be. And actually the neutrophil, it's hard to confuse that. So if you were asked for a basophil, yes, that's a little more difficult, or a lymphocyte. But in each case, and say a monocyte, look at the size, but also the nuclear lobes in this. So that is sufficient for that particular question. Now, a second question was name the feature that is circled in the web-like image. And in this case, the structure circled is a central artery in the spleen. Now, one of the things you're learning in this course are patterns, and this is a clear pattern of a lymphatic nodule with a light terminal center with this arteriole off to the side. Very typical pattern in the spleen and absolutely unique to the spleen to have an artery associated with the lymphatic nodule. So I'm going back to that particular question. You should have chosen the central artery. So now we'll move on to the next image. I need to get rid of this one and question 3. Match the regions marked X, Y, and Z in this large blood vessel with the correct term. So let's look at that image. And you see here we have a low power, and you can see some adipose tissue out here, and then we look in here, you see adipose tissue, and you see actually a blood vessel, one here and one here. And so if you're looking at an artery, and actually the question asks about a blood vessel. So you already know you're dealing with a blood vessel. And in this case, it's a large blood vessel or elastic artery. So you see the enema here and the media here with the multiple layers, up to 70 layers of elastic fibers with collagen between and fibroblasts, and then the adventissue, which is mostly collagen with some adipose tissue. So hopefully that will help you remember a large artery. Go to the next question, question 4. Identify the tissue shown in the web-like image. Okay, and your choices are striated cardiac muscle. I notice a slight misspelling there, and I'm sure you assumed that was muscle, dense, regular connective tissue, loose connective tissue, dense, irregular. So let's take a look at this. Now we have a low power and a high power, and it's all very red, and you know that all of these, unless we tell you otherwise, are stained with hematoxin eosin. So here you have a very reddish stain, and so you have to conclude that it's mostly eosin reacting with the tissue. And what reacts that strongly? Well, what you've learned is mostly collagen, except for, say, an eosinophil blood vessel or blood cell. So if you look at high magnification, you see flattened nuclei, and you see these thick, very eosinophilic structures. And these are collagen fibers, and the fibroblasts, these lie alongside. Would not be smooth muscle because you would see the nuclei within the reddish stained acidophilic collagen fibers. So hopefully that will help on that scale. So you would choose dense, regular connective tissue because everything is aligned in one direction. Okay, the next one, name the area of bone formation that is between the yellow lines in the web-mic specimen. Okay, let's take a look at that. And between the yellow lines, well, hopefully you would immediately recognize that this is epiphyseal plate. You have the cartilage, then you have this pattern here, which reminds me at least of bone spicules. And so between that, you have the area of zone of ossification or bone formation. So you would have chosen there the zone of calcification. And just to review the zones, you have the resting zone over here where there's no, it's kind of a random organization of the chondrocytes. But then here, they're rather lined up in a linear fashion. So that's the zone of proliferation. And then you see that the chondrocytes are getting larger. So this would be a zone of hypertrophy. And then the zone of calcification where the cartilage has become calcified. And then after that, the zone of ossification where you've got the pink collagen dominant osteoid being deposited upon the calcified cartilage spicules. Okay, question 6, identify the specific muscle structure indicated by the arrows connected to the number 4. So when we look at that specimen, this is an iron hematoxin stained striated skeletal muscle, and you see the banding here. And you're asked specifically, you're giving numerous examples of this light area right in the dark band. And you know, the light band is I band and the dark bands are A bands, and that's where the myosin is and the actin's here. And of course the actin interdigitates with the myosin and the A band. And if it's not contracted very much, then you're going to have a zone in the middle here, and that zone is the H zone. Or you could have typed in H band. We gave you credit for a variety of answers, or even one letter misspelling. Okay, so that is question 6. So question 7 asks, name the type of muscle tissue featured in the web-mic specimen. So the type of tissue featured here is very eosinophilic. You see rather round, not perfectly round structures, but as a whole, they're really intact. And you see nuclei here that are on the edge of those eosinophilic structures. So that suggests the nuclei are on the very edge of these structures. And so you're asked what type of, let's go back here, the type of muscle tissue. So there are only 3 types of muscle tissue: skeletal, striated, cardiac striated, and smooth. And so if it were smooth, you would see nuclei in the center of these eosinophilic structures. And if it was cardiac muscle, you would also see nuclei more or less in the center, and you would see a very irregular profile, because remember, cardiac muscle branches. So a cross section, you would see appendages sticking off here. So this is striated skeletal muscle. Okay, you're asked to name a feature or identify a feature, and you're given choices that really all have to do with bone tissue: canaliculi, Volkmann's canals, lamella, and so forth. So if you look at the specimen, you immediately see that it has these little thin lines, and that should remind you immediately of canaliculi, because like this would be a lacuna with a nucleus of osteocytes in the lacuna and the cytoplasm. And of course the processes of these osteocytes extend into the little canals. And The Latin term canaliculi means little canals. So the answer to that question really is unequivocally canaliculi. Okay, so we'll go to the next question here. From back, you would have chosen canaliculi. So the next question, you're asked to name a cell type circled in the web-like specimen. You're given really white blood cell choices. So now you got to be thinking about the various characteristics of the white blood cells. So here you have your erythrocytes. Looks like a pretty normal blood smear. You've got a clump of platelets over here and some isolated platelets around. And this is the cell in question. Well, first of all, it's small. It's about the same size as a red blood cell. And you just see a tad, barely bit of cytoplasm blue off to one side. And so that should immediately remind you of a lymphocyte. Certainly not a monocyte, because monocyte's much bigger than that. You'll see a lot of cytoplasm around it. And the eosinophil and basophils are much different. So that should be rather straightforward. So we would have chosen monocyte for that question. A lower and higher magnification of blood vessel in question 10 is presented, and you're asked to identify the structure indicated by the black arrows in the higher magnification. So let's see what that is. You've got your choices here of collagen fiber, external elastic membrane, etc. And so let's take a look at this. Okay, so on the low mag, you should immediately recognize that this is a pattern of a hollow organ. You've got your lumen, and then you've got your layers. In this case, it would have three layers: an intima, media, and adventitia. And the media here, shown at high magnification, is highly organized, very dense population, smooth muscle cells. The intima here, and let's go back and see what we were asked now. We were asked to identify the structure indicated by the black arrows. So we go back here, and we see this wavy structure here in the intima, and that should remind us of an elastic membrane. So this is the internal elastic membrane. That is the answer that should have been chosen. Okay, on this one, they identified the tissue lining the lumen, labeled as L in the web-like specimen. Okay, you're given this as trichrome stain. And your choices are pretty much all the different types of epithelium. So when we take a look at that, okay, we see here the bluish or greenish stained connective tissue. So from here on out would be the epithelial tissue. Now you see multiple layers of nuclei, which means it's a stratified epithelium. But then look at the surface cells. Look how large and round they are. In fact, they even remind you in some places of a dome. These are a little flattened here, but look at the nuclei. They're not flat, they're round. It can't be stratified squamous, non-keratinized, and it certainly can't be stratified squamous keratinized, and it can't be stratified cuboidal. So it must be transitional epithelium. So we go back, and you would choose transitional epithelium. Okay, here we have question 12. Select from the list the correct identification of the cell type represented by the cells indicated by the arrow. So the choices now are fibroblasts. Now you should be thinking, okay, flat nuclei, endothelial cells, yes, really flat nuclei. T lymphocytes, round nuclei. B lymphocytes, round nuclei. Dendritic cells, okay, those are in the lymphatic nodules, and they're kind of ovoid nuclei, and they tend to be somewhat euchromatic. So, you know, with that knowledge in the background, then when you look at the specimen, then you look, okay, here are a lot of round nuclei, so we know it. And they're not being pointed to, except for these, which are rather clear. Here are dense nuclei, and there's one. You can see a nucleolus in that one. Here's a very large euchromatic nucleus. Here's another one. You can see a nucleus in it, and another one here. Well, you don't see that in lymphocytes, T or B. You see these are dendritic cells, and they're in a lymphatic nodule. So now going on to question 13, to name the type of bone formation occurring in the web-like specimen. So looking at that specimen, here we have, you saw this in another question in the test, asking the specific area. But this is just asking the whole thing, you know. So is it, what type of bone formation is this? Well, endochondral bone formation would have no cartilage involved in it. So you see cartilage, so immediately you have to think there are only two types of bone formation: endochondral ossification, or bone formation, and intramembranous. So it is intramembranous. Here we have name the tissue represented by the web-like specimen in question 15. And you're given choices of 3 types of cartilage and 1 type of connective tissue, dense regular connective tissue. So let's take a look at that. And you say, okay, you have an overall kind of bluish staining, and you see these spaces with little dots in them, and those are nuclei. Sometimes you can see some cytoplasm here. And so this reminds me of the pattern of a cartilage. And it is all, there's no particular orientation to it. And you see the matrix is rather smooth. So I'm concluding of the 3 types of cartilage, this is hyaline. It's certainly not dense, regular or irregular connective tissue. So I would have typed in, or I would have chosen hyaline cartilage. Okay, here in question 16, you are asked to identify a blood vessel shown in the web-like specimen, and you're given a low and high magnification, and the stain is golden or trichrome. So immediately remember trichrome, the connective tissue could be blue or green, and the cytoplasm would be reddish. And so now we're going to look and see if we can determine what this is. Well, you certainly are not seeing a lot of, in the lumen side, you're not seeing a lot of muscle. You're seeing most of the connective tissue in the inner part of this, which would be your media. And you look here, this would be your enema here of this vessel, this would be the media, and then over here is the adventitious. So you see these kind of cross-sectional views, and this reminds me of smooth muscle in cross-section, because you would see ovoid or elongated patterns here if this was longitudinal sections through these smooth muscle cells. So what vessel has this? Well, it's a large vein, like a vena cava, where the adventitia has longitudinally oriented smooth muscle cells in bundles. So the answer to 17 would have, or excuse me, of question 16 would have been large vein. The next question, 17, is asking us to identify the epithelium bordering the space labeled as S. So we're going to look at that space. We're given all these choices of the epithelia. And as I look at this, okay, I see the connective tissue here, and I see the epithelium is all, the cytoplasm is acidophilic, staining with eosin. I see the nuclei, they're ovoid, that reminds me of columnar in terms of an epithelium as far as the shape of the cell is concerned. Then I'm going to look here and I see that there's a single layer of nuclei. And I look at, what is the dominant feature here, and that certainly is. Even here, as there's a little elevation here, you maybe have a couple of nuclei here, but what is the dominant pattern? And the dominant pattern is a single layer, so this has got to be simple columnar epithelium. Now, some of you, I know, confuse this with pseudostratified, but for pseudostratified, you've got to see the whole area is totally confused. You'll have nuclei stacked on top of each other, but not any clear 2 layers. So this is definitely not stratified. Okay, this is question 18, and you're asked here to identify a specific tissue type in the web-like specimen, and you're given a low and a high magnification, and you have to type in the answer. So here's your low mag, and here's your high mag. Again, here, dominant eosinophilic staining or acidophilic reaction in the staining, taking up eosin dye in a strong manner. And at the high magnification, you see you have these structures here that are very eosinophilic, and you see a longitudinal profile, and then you see a cross-sectional profile, and occasionally you'll see a nucleus. Well, these are fibroblasts, and these are collagen fibers, and this has got to be dense, irregular connective tissue. So we would have typed in dense irregular connective tissue for 18. Now 19 is asking the specific tissue type also, and two different stains are presented. So let's take a look at those. Okay, you see the H&E up here. You'll see some nuclei that look like they have little clear areas around them occasionally, and a lot of dominant eosinophilic staining. So this should remind you of a lot of collagen. And then down here you have this methanol yellow, and you can see the collagen is staining yellow, and you can see nuclei and little clear areas around it. So it reminds me of chondrocytes, but they're oriented in a specific direction. Up here, there's some orientation. It's clear down here. And with the collagen between and the chondrocytes, it's got to be fibrocartilage. So question 20 asks the nuclei indicated by the black arrows belong to which of the following cell types? So you're given a choice here, and you've got your adipocytes, lymphocytes, mast cells, fibroblasts, mesenchymal cells, and plasma cells. So let's take a look at this and look where the arrows are. Okay, there's a thin, flat nucleus, not so flat, but fairly ovoid shape, another thin, flat, ovoid shaped nucleus. And you look at these three nuclei, and they keep a lot of company of the same type of nuclei around, except for these. These would be lymphocytes here. And you see the dominant eosinophilic staining of these fibers. These are collagen fibers, so it can't be anything else other than fibroblasts. If it was a plasma cell, you'd expect to see some cytoplasm and a more rounded nucleus. If you're lucky, would be eccentric. And of course, I just pointed out lymphocytes would be another possibility. For question 21, you're asked to name the layer indicated by the number 1 in the large view of this appendage of skin. And you've got to type that in. So let's take a look at that. Okay, and actually in that question, you're just given an appendage of skin. So you have to recognize this pattern. You see some bone tissue here, you see what looks like skin here, and this should remind you of the nail. And so number 1 is the nail bed, number 2 is the nail, number 1 is the nail plate, number 2 is the nail bed, and number 3 is the dermis. So you're asked about which one. It says by layer number 1, so that would be the nail plate. For question 22, you're asked to name the region that is spanned by the yellow lines in the web-like specimen. So you're given the choice, the cortex of the spleen. Well, immediately you should recognize there is no cortex of the spleen. It does not have a cortex of medulla. Superficial part of a tonsil, well, it could be that. Outer cortex of the lymph node, yes, it could be that. Cortex of the thymus, yes, the thymus has a cortex of medulla. Inner cortex of the lymph node, yes, the lymph node has an inner or deep cortex. So if we take a look at this, the yellow lines are spanning. Well, first of all, notice that dominant is hematoxylin staining. What cell type packed close together would get that many? It would have to be lymphocytes. And so here you look in the outer portion, you see that there are two regions, a lighter and an inner. And this would be a cortex, and this is be a medulla. Here's an eosinophilic or collagen-rich capsule. And there are no rounded structures like lymphatic nodules, so we have to include this. It's the thymus, and this is the cortex of the thymus. Okay, the next question, 23. Name the feature of bone indicated by the arrows in the web-like specimen, and you got the stain is thine and picric acid. And all your choices have to do with bone structure. So when we look at this, we immediately see the pattern here. It should remind you immediately of layers. You see all these little fine, looks like a spider's web. Those are candiliculi, those are osteocytes, and they're arranged like a universe or a Hertzian system around this empty area that has maybe a blood vessel here, but mostly space, because the blood vessels have been either shrunk or washed out. So these are Hertzian canals. These are where the blood vessels run. in bone tissue, and this is compact bone tissue. Here on question 24, you're asked to name the cells that are circled at the top of the Webb-Mike specimen. And they're giving choices: osteoblasts, lymphocytes, chondroblasts, chondrocytes, osteocytes, osteoprotein cell, osteoclasts, etc. So we look at this, and immediately we see these rounded areas. You see a little space around. You see the nuclei. You see the cytoplasm, and it should remind you of the pattern of cartilage. So you're asked about these, and you see the eosinophilic layer here would be the fibrous perichondrium. This would be the osteogenic or the chondrogenic perichondrium, where the chondroblasts are being formed that are eventually going to grow and change into what we call chondrocytes. So what was the question? The question was name the cells that are circled, so those would be chondroblasts. So then the last question is, which of the numbered structures indicates a nerve fiber in this Webb-Mike specimen? And you're given these numbers. So we got 1, 2, 3, 4, 5. We have to make a choice here. So we're looking for what defines a nerve fiber. So when I look at this now, okay, I see 5. Well, that's enclosing a structure. I see a little dot here. I see maybe a space. Over here, it's more clear, the same thing, 5. I see a dot. Well, that reminds me of axon. The clear space and the H and E preparation reminds me of the myelin sheath. The darker structure here is a nucleus, and cytoplasm reminds me of the Schwann cell. So when you take a Schwann cell, you take the myelin sheath that the Schwann cell formed, and the axon, that defines a nerve fiber. So I would have put number 5 as the best answer for this question, making sure it did ask for, yes, a nerve fiber. Okay, now the next thing I'm going to do is just look at a few questions of type in and show you a number of different types of answers that we accepted, and that'll conclude this review at Part B. Okay, here is the fill in the blank question, and the correct answer, as I've already discussed with you, was dense, irregular connective tissue. And you can see that 73% of the class chose the correct answer. But this is what we see that Blackboard gives us, and these are all the various answers that were typed in. 2.5% of the class typed in smooth muscle, and you just didn't realize that the nuclei have to be in the center of these structures that cause smooth muscle. But I don't want to dwell on this, but I want to show you what we get credit for: dense, irregular connective. We didn't require you to put tissue at the end. You got credit for that. You got credit for dense, irregular connective tissue. You got credit for dense, irregular, which is assumed you knew it was connective tissue, and dense, irregular tissue. So we also accepted, but loose and irregular, those are opposites. You can't choose that. So that gives you an idea of the different answers that were given, and some of them are, off base, and so you need to think about that for future things. And then the next question here, fill in the blank, identify a specific cell type. This was a smooth muscle cell, and we had people put in tendon cell. Well, when you see the nuclei in the center of the cytoplasm here, it just can't be a tendon cell, and it's not a fibroblast, but some people thought they were osteoclasts. But the permutations of the correct answer were smooth muscle tissue cell, and smooth muscle cell. And then the next fill in the blank question, that was the one where there was the H zone. And unfortunately, inversing canals is way off. As some of these, excuse me, A band, M band, and Z line, none of those are possible. Look carefully here. This is the light zone in the middle of the dark band, which is the A band. So we accepted H zone and H band. And we also accepted H band without a hyphen. And we accepted H zone with a hyphen. So you see, those are the answers that were accepted. And you can see that we're trying to be very fair about this. And then the last one, fill in the blank, And the answer was a nail plate, and 93% of the class answered that correctly, but some said it was epidermis. Well, not so. This is the nail. Some said it was the nail bed. Nope, that's the next one down. And then dense irregular connective tissue, that would be down here in the dermis. And these, of course, are not anywhere near the correct answers. So that concludes this review. I hope it is helpful, and then as you study for the final examination.